Okay, the x-intercepts of a function are called zeros. A polynomial function with n degree can have at most n real zeros. So where do I find the degree? What is the degree? It's the highest exponent, right? So an even degree is going to have an even number of real zeros, and an odd degree is going to have an odd number of real zeros. So the solution to the equation f of x equals 0 are the zeros, and they are called roots. If x equals c, then x minus c is a linear factor. Linear factors can be found by factoring the polynomial. And so that's why some of you were missing, because after you factored the x minus c, the root changes sign, right? So if it's a minus here, it becomes a positive. So if c is positive, it's a negative when you factor. I don't know why this is doing this. So f of x equals x cubed plus 5x squared minus 24x. So first of all, how do I have to start? Take the x out. So I get x squared plus 5x minus 24. So when I do a times c, so the zeros end up being 0, -8, and 3. So if I'm going to find the zeros, I'm going to start with number 2. I'm going to take out the x. So I get -6 and -5. So my factors are going to be -6 and 1. But I have a leading coefficient. I can reduce the first one. It would, but do I want it to be 4x squared, or do I want it to be 2x to the third? Because the leading coefficient is 2x, so you have to put that here and here. That's how you do it. The leading coefficient always goes there, and then I can reduce this one by 2, so x times 2x gives me my 2x to the third. Do you see or no? Okay. So once it's factored, if I set it equal to 0, that's how I'm going to get my roots. So my roots are 0, 3, and then a -1/2. So I want to do the same thing on number 3, where I'm going to take a times c, and there's no leading coefficient this time. So it's 4 and -5. So I'm going to have -4 and -1. But this time I do have x to the 4th. So I'm going to use x squared minus 4 and x squared minus 1. And then these are perfect squares. So once you set it to 0, you can get all the zeros then. You get plus or minus 2 and plus or minus 1. We're going to do the exact same thing for this one. If I take a times c, I'm going to get 36 and negative 37. So what factors am I going to use? Right, negative 36 and negative 1. So my f of x is going to equal 9x squared minus 36. And Joseph, this is another one. Look, it's a 9x. So I'm going to put 9x on both of them. So I'm going to start like this. So then I'm going to look at the first term. Can I divide out a 9 on the first term? So then I end up with x squared minus 4 and 9x squared minus 1. And both of those are perfect squares then. So this one factors to x plus 2 and x minus 2. And this one factors to 3x plus 1 and 3x minus 1. And if I set that equal to 0, then I can get all the roots. And the roots are plus or minus 2 and plus or minus 1/3. Okay, so look at number 6. The difference with number 6 is it's not 3 terms, now it's 4, so we have to do factor by grouping. So the first one is going to be 4x squared. And that'll be times 5x minus 3. And the next two that I look at, first of all, it's a minus sign, so I have to divide by negative. And did they have anything in common? No, so we have to make them a 1. So I'm going to have minus 1, and that changes the signs. But now these match. And the 4x squared minus 1 is a perfect square, so we have to factor that. This is 3. And if I set it equal to 0, then I can get my answers. So I get 3/5 and plus or minus a half. So look at number 8. First of all, I can't factor with the negative in front. So I'm going to have to factor out a negative out of here. And what do they all have in common? X squared. So I'm going to take out a negative x squared. And when I do that, I end up with x squared minus 6x plus 9. And then this factors to negative 3 and negative 3. Which I can write like this. So from there, I can get my zeros. So when x equals 0, what they're asking for this time is the multiplicity. And by multiplicity, what I mean is the parentheses are the linear factors. The x, the 3, and the 3, right? Those are my linear factors. Multiplicity is the exponent on the outside of the parentheses. So what's the exponent outside the parentheses? So this time, the exponent outside the x is 2. And what do we say happened at 2? It's a bounce. So it's a multiplicity of 2 and it's a bounce. What about at x equals 3? What's the multiplicity? It's 2. So it's also a bounce. So there's 2 bounces in that polynomial, okay? So if we look at the next one, it wants to look at the factored form. So if I have f of x and I take out the x, so the factored form is x times x plus 2 squared. Well, here's why you're going to have to, because when you're graphing, you're going to need to know where your bounces are. So if you don't put them together, you'll end up not getting it right. So when the multiplicity is even, the graph is tangent to the x-axis and it's a bounce. When the multiplicity is 1, what do we say happens when it's 1? It goes right through the axis, right? So it intersects the axis. And if it's greater than 1, then it's a point of inflection if it's odd. So if we were going to graph this, I'm going to have 0, 0, and I'm going to have negative 2. So what's happening at negative 2? It's a bounce. And if I put in 0 in here to find y-intercept, what's 0 times everything? 0. So the y-intercept is 0, 0. So next, I have x to the third, and the leading coefficient is positive. So what does the end behavior look like? Down and up. So this is down, and this is up, right? And where's the bounce? Right here, correct? So I'm going to go up, bounce, and up. Okay, so the last one, what are the zeros here? The first 0 is 1, and then 3 halves, and negative 4. What's the multiplicity at 1? 2, and 2 at 3 halves, and the multiplicity at negative 4? 1. So the effect is a bounce, bless you, and an intersection. For the last one, you have to factor out what they have in common. So I get 4 and 4. So when I write this, and so this is, so Joseph, you were asking, am I going to count it wrong? But look, right here, if I don't put squared, then I don't have the right multiplicity, okay? So the first is 0, and the second is negative 4. The multiplicity is 3 and 2. So at 3, that gives me a point of inflection. And the 2 gives me a bounce, or a tangency.